Hello everyone, today we're looking at two relatively easy number theory problems, and I believe we probably wouldn't even need calculators for. So, wait, which one is it? Yep. So, we have to first prove that there's no integers abc for which a squared plus b squared minus 8c is equal to 6. I believe I probably wouldn't even need like scratch paper for this because it's just like knowing the properties. Okay, not really, but we can pause the video first and think about this problem yourself. It should be pretty easy if you know the trick. So basically, I feel like I don't know if it's really a trick, but for this problem is that you should always know when you take squares mod a number, there's always properties. And in this case, the properties of squared, which a squared or b squared, they're both square. Any square mod 8 can only be 1, 4, or 0. And if you think about it, that makes a lot of sense. Because if you don't have a factor of 2, then it's 1. If you had, okay, I don't know how to explain this, but it does make sense that it only mod to 1, 4, or 0. And you can't make a 6 in any way with 2, 1, 4. Because, well, obviously, if we change this into a modular congruence, the right side is going to be a 6, the left side is just going to be a squared plus b squared mod 8 because minus 8c is going to be 0. So a squared plus b squared can each only be 1, 3, or 4. There is no way you can make a 6 out of 2, not 1, 3, 4, 1, 0, 4. There's no way you can make a 6 out of 2, 1, 0, and 4. So QED. The second problem is we have to find the greatest integer that will divide these numbers and leave the same remainder. This is also just like really, really easy. I don't know why it's in the intermediate number theory problem category, but it will just be whatever the greatest integer that divides their difference, because well, obviously same remainder means that their difference divide this number. So if you do some very brute calculation, you'll see that the answer is 98. Okay, maybe we'll have time to do even another one. 71, 7. Nope, not this one. Yep, this one's 71, 7. So we're looking at three problems today then, I guess. So this one's a little bit more interesting. Let n be a 5-digit number whose first digit is not 0, and let n be a 4-digit number formed by removing its middle digit. Determine all of the n such that n over m is an integer. Let's pull up VS Code. All right. So basically, we have A, B, C, D, E, and A, B, D, E. And if we actually express it in decimal form, it's going to be 10,000 times A plus 1,000 times B plus 100C plus 10D plus E. And the bottom one is going to be M is going to be 1,000 A plus 100B plus 10D plus E. Right? So we know the top one is divisible by the bottom one. And there's not really anything that we can conclude from this divisibility. However, we can use kind of a trick that is very similar to the one that we used on the last problem, in which we take the difference of those two, which I guess is not exactly the same thing, but we can take the difference of those two, and they're still going to be divisible by the same number. So when we take the top one subtracted by the bottom, also another motivation for us to do this is because these two are in very similar forms, which means that if we just subtract them, it's going to give us a pretty neat expression. This will give us, what is it, 9,000A plus 900B plus 100C is divisible by this expression. Okay, now we can take a look. Notice that since A, B, D, and E, well, I guess C2, are all single-digit numbers, which means that there is no way for this expression to be true if the factor that we multiply the left side by to get the right side is not 9. If you would think about it, if it's 8, it is obviously going to be too small because B is only one digit. If you multiply by 10, it's obviously going to be too big because, well, B is only one digit on the right side as well. So the only possibility is if we multiply it by 5. I mean 9. I can't speak today. That will give us the left side. What basically we multiply that by 9, and it'll turn into 9,000A plus 900B plus 90D plus E is equal to this expression, correct? So now, notice that the only possible D, E, and C, because, well, those cancel out, obviously, the left terms cancel out. We'll just delete those. Those have to be equal. So the only possibility for D, E, and C to satisfy this equality is if they're all 0. Think about it. Because D and E are 1 digit, C is also 1 digit, there is no way to do this except for letting C equal 0, first of all. And if C is 0, obviously D and E are also 0. Okay, so we just basically solve this. D, E, and C has to be 0, and everything else just automatically satisfied if we just multiply this by 9, and that's all we have to do. So basically, multiples of 1000 are the valid answers for this problem. Okay, thank you for watching, and I'll see you tomorrow. Okay, haha, this video is not actually over. Here's the grind report, and also I learned my lesson from making musical videos, and I realized that if I just say, bye everyone, and see you next video, people who doesn't know there's a grind report will just click out of the video, which is a good thing, because I don't want random people just hearing me yap about non-math and non-coding stuff. So basically, today I actually did quite a lot, because it's a weekend day, and I feel like I'm just obligated to do a lot of math now that AMC is 10 days away. However, I still didn't do nearly as much as I expected, because I was expecting basically like a musical level grind of like 10 hours, I guess. But I got like 5 in, including this 5.5. So I guess good enough, better than like 1 hour of usual days. So I did 8 introductory number theory problems, which is really, really disappointing, because I thought these problems are going to be like 10 every hour, but it turns out to be like 40-minute per problem. So it's pretty bad. Like 40 minutes, I can do a short coding problem with that amount of time. So I don't know if it's because I'm improving, or if the problems are too hard, or is the type of grinding is just not good, or maybe math problems are supposed to take a lot of time. But 40 minutes per problem is still a little bit too much. Also, number theory, I feel like, is one of my really, really important weaknesses, because out of these 8 intermediate number theory problems, I was only able to solve completely by myself. I was only able to solve, I believe, 2 of them. And also in my keeping track of problems, I've also included a new scaling, in which I just put a number in front of it instead of using colors, which, I mean, colors are more straightforward for Usico, but now I need to actually distinguish between algebra, number theory, combinatorics, and geometry. So I have to use colors for that. I'll have to use numbers for difficulty. Okay, thank you for watching, and I'll actually see you tomorrow now.